We are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of Read Code and Geeks for Geeks. So without wasting any time, let's get started. Today's problem is maximum sum of non-adjacent nodes, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given the root node of a binary tree, and what we have to do, we have to select a subset of nodes. Subset of nodes basically means any possible combination of nodes such that sum of their values is maximized, okay, and with the condition that no two selected nodes are directly connected, okay. So we have to select a possible combination of nodes such that those selected nodes, their parent and their children are not taken and their value is maximized, okay, and we have to return the maximum possible sum. I think the problem statement will be a bit clear to you. So look, if I'm taking this node 11, I cannot take this node 1 and I cannot take this node 2 as well if I'm taking my 11 this node, okay. Why? Because these two nodes are its children, which I cannot take, okay. All right, moving on. If you will see this example here, if I am selecting 2, I cannot select this one node and I cannot select this 4 node as well. Why? Because these two are connected with this node. If I'm considering this node, I cannot take its parent node, I cannot take its children node. If I'm selecting this 3, I cannot select this parent node 1 and I cannot select its children node 6 and 5. Okay, all right. So this is one example, and now one very beautiful observation here is that, look, if I am selecting this node 2, I cannot select 1 and 4, but I can select this 3 node. I can select this 3 node. Why? Because they are not, these two are not touching. They have a common parent, but there is no connection, direct connection between them. Okay. So if I am considering any root node, I will now consider its children's children, like this. If I'm considering one, and if I'm not considering the parent node, I will consider the both siblings, because we have to maximize our result, okay. And tree's value will always be positive. So why take only two? Why take only this node? I can take both nodes, so this apply for all, okay. All right, so I think the problem statement will be very clear to you. Let's move to one node and try to understand the approach, okay. All right, so look, my approach will be basically recursive approach I will use. So look, either consider the root node, either consider the root node, or consider uh, their children, or consider their children, okay. All right, so these are the two possibilities. And if I'm considering the given root node, next nodes which I can take is root dot left dot children. Root dot left dot children means root dot left dot left and root dot left dot right. Similar for this, like I'm considering root, so I cannot consider this root dot right, but I can consider root dot right dot left and root dot right. Okay, so basically means this node and this node, okay. So these. So if I'm considering root, I will take its grandparents and move on. And if I'm not taking root, so their children 1 and 2, both these sums I will consider and move on. Okay, all right. So let's take this approach for this example. Look, if I'm considering root node 11, okay, so one possible sum is 11, and then root 11's dot left which is null 0, dot left dot right which is null 0. Similarly for this 2 as well. So if I will consider root node 11, my sum will be 11. But if I will not consider root node, I will consider both of its children. Why? Because I have to maximize and their values will always be positive. So I will always consider their sums. Okay. So it will be something like 1 plus 2 So look, 1 plus 2, and now there is no grandparents of this one node, neither of these two node. So there are only two possible combination. One is 11, one is 3. Which one is maximum? 11. So my answer will be 11. Okay, all right. Now let's consider this second example. Here again, if I will consider root node 1, okay, then I cannot consider this 2 and 3. Okay, then what I can consider? 4, 5, 6. So my sum can be anything like 1 plus 4 plus 5 plus 6. Okay, and if I am not considering this one, if I'm not considering this one, my sum will be the my answer can be the sum of its siblings, like moving on. Okay, so 2 plus 3, and there are no of its grandchildren, like 4 children there are no, and 5 6 children are also no. So only possible sum is 2 plus 3, which is 5, and here it is 6 4 10 16. So which one is maximum? 16. So I will simply return 16. Okay, all right, moving on. So here you can see, like, I am either considering this or and its grandchildren or its children. Okay, something like this. Moving on, let's take another example, this. So here look, 13. If I will consider 13, I cannot consider this 4 and 5. Okay, I cannot consider. Okay, then what I can consider? 1 2 6. Okay, so if I will consider 1 2 6. Okay, yeah, look. So if now 13 I am taking, and I am taking 1 2 6. So what will be the sum? 13 plus 6 to 8 9, which is equal to what? 22. I think you guys are getting and are with me till this point. Okay, my sum will be 22. But if look, 13 I am taking, now 4 5 I cannot take, but should I consider this 1 or should I take this 10? Because look, we have to try all the possible combinations. So if I'm taking 13, uh, I will take 2, I will take this 6 as well, but I will not take this one. I will not take this one, because if I will take one, I have to miss this 10. But one value is less, 10 value is greater, so I should consider 10. So that's why I will miss one. Okay, so in this way you can see we have to try all the possible combination. There is no rocket science, there is no logic. Try all the possible variations, and whatever maximum result I get, we have to simply return it. Okay, all right, so this is our way. And when I'm going to write the code, basically I'm going to explain step by step while writing the code as well. So let's move on to the code section, where we will understand how are we going to approach this. I think how are we going to write the code, and the approach will be very clear, I guess. Okay, but before that, if you have got the approach, please subscribe the channel, like the video, and also I have made a very cool Chrome extension for you. You can see this button here where you can add some more problems. If you are taking help of it, simply click add for review and it will be added here. Okay, so for the revision, so that you can revise, and I have made a LinkedIn post for it as well. So make sure to check it out, like, comment on this post as well, and try this extension. Okay, all right, moving on. Okay, so what I'm going to do, simply make a function return, and let's name it anything. Let's name it get max, pass the root, and here static int get max. And if you are coding it in C++, guys, look, the logic will be same, only syntax will change. So I think you guys can manage it. And yeah, so if at any point my root is equal to null, if at any point my root is equal to null, what I'm going to do, I will simply return 0. Okay, otherwise look, there are two possible ways. Either you consider this root or you don't consider. Okay, so suppose I will consider this root. So my sum will be what? Root dot data. Okay, and after that, now I have to consider root's grandchildren. grandchildren, I think grandchildren is correct word, yeah. So if root dot left not equal to null, and guys you have to visualize this, so please sit with pen and paper as well if you are a beginner in recursion. Okay, so now if root dot left not equal to null, so I will move to the children of root dot left and consider them. So sum plus equal to get max of what, root dot left plus get max of root dot left dot right as well. Okay, similarly we will do for right as well. For the right children of root dot right, and if it is not null, what I'm going to do, root dot right dot left and root dot right dot right. What it is saying doing is basically considering the grandchildren of this root. Okay, all right, and this get max sum will always return me the maximum possible sum till this root. Okay, all right, and after that what I'm going to do, I'm going to simply return what, return maximum of current sum. Like current sum is basically when I'm considering this root node, and otherwise if I'm not consider this root node, I will consider the sum of their children nodes, like get max. Okay, so it will be something like get max of root dot left and root dot right. Okay, something like this, and I think it should work. Sorry, what I'm doing, something like this. Yeah, correct. Let's try to compile this, and guys it's not over. We have to do memorization here as well, but let me show you. So if I will try to submit, it will work, but I think it will give me time limit exceed. Yes, it is giving me time limit exceed. Why? Because we are trying all the possible variations, and yeah, we are trying all the possible variation. So how we can improve it, let's quickly see. So here you can see that if suppose there is very much tree here, something like this, and then there is this, and then there is this node, and then there are more nodes. Okay, something like this. And now uh, look, if suppose this root node 10, I will come, if I will take this 4 node, if I will consider this 4 node, I have to get max, I have to get max till this. Okay, get max function will be called for this node 10. If I'm taking this 13, again get max of 10 will be called again. But look, this get max of 10 will always return me the same answer. So why not add, why not store it, why not store it once, so that if again get max of 10 is called, I can simply return instead of calculating again, I think you guys are getting this. So look, 13 4, and there can be more ways as well. If I'm considering this 2 node, again I have to get max of 10. So get max of 10 answer will always be same, which we have to store it, so that we don't need go on calculating it again and again, which we are currently doing. So how can we store it? We can simply use a map for that. So let's do map of node type, and key will be node, and its value will be integer, something integer. Okay, mp is equal to new hash map, something like this, and pass this map here mp, and get it here easily by writing this again. Okay, please be with me, and if root is equal to null, return 0. And now before calculating it again, just check here if I have already calculated it. If yes, so if I've already calculated, let me wait, I will explain. So now look, after getting, what I'm going to do, I'm going to store it somewhere, so instead of returning, I will store it something like mp map dot put what, root comma root node, and its value will be this. Okay, root node and its value will be this, something like this. And now I will return mp dot get root. So what I'm doing here, I'm just storing this map, this result, this root node, if root node for get max for this root node, I'm storing, so that again in future whenever like recursively it gets called again, I can simply return it here. What, how can I return? I will simply do mp dot contains key root. If it contains, simply return mp dot get root. So I don't need to, I will eliminate this process again. I will not do this again because I've already stored it with here. Okay, so that's what it is doing here. And yeah, just pass this mp hash map in all these function, and that's it, guys. I think you are with me till this point, and I will try to submit it. Let's try to compile and run to check if I've not done any silly mistakes. No, I haven't. Let's try to submit this. And please, if you are solving this problem with my video, please like the video, subscribe the channel, and use this extension. Add it here. Add this problem here to revise it again. Okay. So I've explained this whole use of extension on the LinkedIn post. Link is in the pinned comment. Make sure to check it out. Make sure to comment on the post, share it with your friends. It will really help me to uh, reach this to greater audience, and I will be again uploading videos, so make sure to subscribe the channel as well. I'm going to see you again tomorrow. Till then, keep on coding and bye.